All right. So as I said, we were getting into each of these um, six periods. All right. So each of them, of course, have their own unique changes that are going on. So the first one, of course, is the Cambrian, and the biggest thing there is the Cambrian explosion. That's where life diversifies. So much more than it ever did in the era before. Okay. So let's see. Blah, blah. All right. So I just said all this. Yeah. So one of the things to realize is that the sea levels are rising and falling um, during these times. Well, that's actually always been true that the sea levels rise and fall, but that actually has a huge effect on the plants and the animals, um, and it affects marine life as well. Um, all right, so changes that contribute to the diversification of life forms. All right, there's the Cambrian explosion. So there is one of the things. Okay, so there's many different life forms, but one of the things that we have really strong evidence for is the trilobite. All right, so let's see if I can find a picture of a trilobite. Because of the hard body nature of these Cambrian creatures, which we found all over the planet. Let's see, land masses. Um, okay, no, not quite there yet. All right, so Cambrian here. Like I think I have a picture of one right here. Just give me a second. Oh, there's a picture of a trilobite. Okay, so we see this fossil, these fossils all over the place on the Earth. So they basically could be described as a and they have been described this way as an armored cockroach. Okay, so they were everywhere, kind of like cockroaches. Um, all right, so that's I mean that's one of the forms of life. There were other forms of life, obviously, but that is probably one of the most abundant forms that we still have evidence of. All right, I'm going to keep referring to this picture where we're at. Okay, so we just talked about the Cambrian period. The next is the Ordovician. And so the Ordovician period, as it says here, we get the first vertebrate fossils. I don't know why I can't say that. Anyhow, so that those are of course creatures with a backbone. That's what that means, of course. All right, so let's dive into that just a little bit. Um, the thing that's here, let's go back to the slides. The thing that's important about this particular period is, let's see. So this is the Ordovician. Um, you get, of course, again, there's a diversification of life, especially marine life. Um, and yeah, there's a picture of this jawless fish. It kind of looks like a sea snake, if you ask me. But anyhow, um, uh, there's also extinctions that are going on. But the biggest thing as far as land goes is towards the South Pole, and this is really important to remember this. This is towards the South Pole. We have various land masses joining to form this continent called Gondwana land. All right, so Gondwana land is like one of the. I mean, it's one of the first continents that people start when you start talking about the geology of the Earth. Uh, that is one of the first continents. So here is Gondwana land. It has um, South America, Africa, India, Australia, part of China is there as well. Okay, so we'll get to this shortly. So, but Gondwanaland is the big one, and the important part about that, of course, is that it's along the South Pole, right? All right, so I jumped to the next period. Okay, so that's the period where Gondwanaland starts to emerge, and then it becomes a supercontinent during this time, right? So it started to emerge, and then in the Silurian period, Gondwanaland becomes a supercontinent, and then what will become North America and Europe begin to converge, and as yeah. Anyhow, that it's right there. Um, all right, so and then terrestrial life. You get plants. There's these things that start to appear to be scorpions and even little millipedes. All right, so this is the next period. Let's see where we're at. And then comes the Devonian period. So Gondwanaland is completely formed in the southern hemisphere. So it takes a long time. This is covering millions of years. It's completely formed. North America and Eurasia join in. So this continent. This thing becomes its own little continent, and it's called Laurasia. All right, so it's called Laurasia, and the thing that's important about the difference between Laurasia and Gondwanaland is Laurasia is near the equator, and so this is extremely subtropical tropical weather that is going on in that time for North America and what's going to become North America and Northern Europe. And look, there's a little piece of Siberia as well. And then and Gondwanaland, of course, is under tremendous amounts of ice, right? There's because it's right on the South Pole. There's glaciation going on. All right. Blah, 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 blah. Let's see. So the Devonian period. Another thing. Oh, so let's remember this. So the Devonian period is known as the Age of Fish. So it's two groups of bony fish. This is actually really important. What are called lungfish, which are still around today, by the way, and these lobe fin fishes, which eventually become the amphibians. All right. So that's they develop kind of like what would be considered their fins can kind of support their body weight, and they can kind of a little bit begin to walk around a little on the land. All right, so that's the Devonian period. All right, and then the next period is really important to us. I mean, they're all important to us. So Gondwanaland and Laurasia collide with each other. So they begin to collide, and this is forming this is. Remember, the Appalachian Mountains are much older than the Himalayas, and also the Ural Mountains in where is that? They're in Asia. All right. Anyhow, they're forming when this collision takes place, and so the big thing here is when Gondwanaland and Laurasia begin to collide, that's ultimately going to form Pangaea. All right, so this is what's starting to happen. This is just beginning. All right, what else? So this is very swampy land, very warm climate, and this is actually where lots and lots of coal is formed. This is the plant life dying in this swampy area and being deposited, layer upon layer, and eventually that will be, all the fossil fuels for the most part come from this time, roughly 3 million years ago. All right. So, there's insects. One of the things is that some of the creatures begin to lay some eggs. These eggs still have to. They're not self-contained in the sense that they don't have like a hard shell around them. They're more like what amphibians would do today. So amphibians, for example, have to lay their eggs in water. That the eggs won't survive if they're not in water. So that this is just a you know just showing us how old that particular life form is. Let's see. Surveys continue to diversify as it sort of links to reptiles and mammals. So this is important. In other words, these things will eventually become reptiles and mammals. So reptiles, mammals actually come from reptiles originally. All right. So the next one is the what's called the Permian period. All right. So let's take a look at where we're at. We'll go back to this picture. So I've taken you through most of these periods in the Paleozoic. All right, so we're up to the Permian period. Okay, so this is the first reptiles begin to emerge. This is not the dinosaurs yet. They are just these really slow reptiles that begin to you know, crawl around the land. All right, here let's get back to this picture. All right, so keep in mind Pangea is. All right, so this is the end. As I said, this is the last period of the Paleozoic era. This is called the Permian, and the thing that's the biggest part about this, the most important part, is this thing that's called the Permian extinction. And huge number. Like it's unreal how much of life went extinct. I mean, it almost wipes out life in general, right? 95% of the life of the marine life that lived in the seas were died off, and roughly 70% of the land creatures died off. And we don't know exactly why. In fact, it's probably not a single reason. And we think that it has to do with, the formation of Pangea, right? Remember, that's going on during this time. And so that causes the redistribution of water and land. So resources have changed. The changing landmass elevations will help, will also drive some of that extinction. The changing climate drives that extinction. Remember that if a life form can't adapt to the change, it will die. It dies out. And of course, there's lower sea levels that is going on, that are taking place. Again, when that happens, of course, you're going to lose, this just incredible numbers of marine life. All right, so let's see. The Paleozoic experienced several fluctuations in sea level. When sea level rises, shallow seas cover the continents. More water is tied up in glaciers to make the climate cool. They're asking us questions. The climate turns warmer. The ocean basins become shallow. So I would say A sounds about right. So shallow seas cover the continents, right? That's all they're saying. That anyhow. All right. So at the end of the Permian period, the sea levels lower. The lowered sea levels could result in, collisions. Let's see. I think it's all of these. Oops. All right. Yeah. So it sounds like all collision of the formation of Pangea, tectonic and climate change, glaciation. Yep. All right. So yeah, I would say all of these contributed to the end of the Permian period, which saw these incredible extinctions. All right. So now we are in officially to the Mesozoic